Hello everyone, welcome to my channel. In this video, we will learn how to create functions. Being able to create your own function is one of the strengths of writing our programs. Knowing how to create a function will make the code writing more efficient. Some examples in this video are adapted from R for Data Science, Import, Tidy, Transform, Visualize and Model Data, by Wickham and Grollman. The reference for this book is listed at the end of this video. There are many advantages to writing our own function. For example, using an evocative name for a function makes the code easier to understand. Writing functions can help us to automate common programming tasks and eliminate the need for copy and paste. If we make changes to our code, we only need to change in one place, instead of changing in multiple places. Suppose we would like to detect the number of extreme values in each column of a given data frame. The extreme values are defined as the ones, with the distance from its mean, that are greater than, or less than 2 times its standard deviation. In this program, each command for detecting the extreme values is almost identical, except for the name of the variable. Our initial approach is to copy and paste the command, and then change the name of the variable. Notice in the second command, that one of the variable names needs to be b, but it still has the value a. This type of error is common, if we are doing copy and paste. Writing a function will eliminate this type of error. Before we write a function, we need to decide what will be the input value for the function. In this example, the name of the variable occurs 3 times in the command for detecting extreme values. Therefore, we should use the name of the variable as the input value. If we are going to use x as the parameter for the function, we need to assign $a to x. Then use x in the command for detecting extreme values within the function body. Now, we have all the ingredients for writing a function for detecting extreme values. First, we need to choose a function name, such as findExtreme. Then we insert the parameter x within the parenthesis after the keyword function. Lastly, we need to enclose the function body within a pair of curly brackets. When we execute the function, $a is passed to the parameter x. During the function execution, x is replaced with the $a. At the end of the execution, the calculated value is returned. After we finish writing the function, we should test the function by providing different values. We might need to modify the function if we see an unusual or unexpected result, or even an error. In the first example, we provide a vector containing 1 to 10 and 100, the function works, and it returns 1. In the second example, when we include a missing value into a vector, the function returns NA. If we cannot figure out where the problem is, we need to debug the function. For example, we can assign the input value to the function parameter, then test the function line by line from the beginning. First, we assign the testing vector to x, which is the function parameter. Then we test the command within the function. Since this command returns NA, it doesn't tell us much about where the problem is. Since there are several functions within this command, we need to break the command into pieces, and start to test each piece. For example, by trying the mean function for x, it returns NA. This is where the problem occurs. By default, if a statistical function's argument contains a missing value, it will return a missing value. To fix the problem, we need to specify the na.rm option to true. Here is the corrected version of the findExtreme function. In this function, all the na.rm options are set to true for all the statistical functions. By default, the returned value from a function is the final expression, or the result that is evaluated from the function. If we want to return several values, we need to combine them into one object. Most of the time, a list object is used to store all the returned values. The advantage of using a list is that we can combine different data types into a list. If we combine them into a vector, the combined values need to have the same data type. For example, suppose that we would like the findExtreme function to return the mean and standard deviation of the given vector, in addition to counting the number of extreme values. We can group these values into a list in the last expression within the function. Instead of grouping them into a list, we can also group them into a vector, but this is not a common approach. To group them into a vector, these values need to have the same data type. It works for this example, since all the returned values are numeric vectors, with a length equaling 1. Even though all the returned values have the same data type, it might not make sense to group them into a vector. For example, if we return a numeric vector and a numeric matrix, we cannot group them into a vector. In this case, we should group them into a list. By default, the returned value from a function is the result from the last evaluated statement. The return function can return a value at any point of a function. We generally use the return function to return a value in the middle of a function. Now, let's create a function for imputing a variable. In statistics, imputation is the process of replacing missing data with substituted values. One method for replacing a numeric missing value is using its median value. We will use the patient data frame to test our function. For example, how to replace the missing value in the GLUC or glucose variable with its median value. Before we write this function, we need to decide the input values. One would be the data frame's name, and the other input value is the variable's name. This function requires writing several statements to impute the missing values. The statements within the function are executed sequentially. The order for placing these statements matters, because the execution of the current statement is often relying on the results from the previous statements. We start with extracting the variable first. Since we assign patient to dat, and GLUC to var name, we should use these two names, dat and var name, in all the testing commands, because we will insert these commands within the function eventually. In step 1, we used character indexing to select GLUC from patient, and assign the result to select var. In step 2, we calculate the median value of select var, and assign the result to replace value. In step 3, we need to replace missing values with the calculated median value. Before we replace the missing values, we can use is.na function to generate a logical vector, indicating which elements in select var is missing. Then we insert this logical index vector within the square bracket, on the left-hand side of the assignment operator. On the right-hand side of the assignment, we will use replace value, which is the median value. In the final step, we need to replace the original column in the input data with the imputed numeric vector from step 3. Finally, we can place all the testing codes within the function. In this example, the order of all these statements within the function is important, because the execution of the current statement depends on the results from the previous statements. Exchanging the order of the statements will not generate the correct result. This example shows how to impute character variables. To impute a character variable, we can replace the missing values with the value of the highest frequency. We can use the table function to build a contingency table of the counts of a given variable. For example, the results from the table function for the HRT variable show us that there are 3 y's and 2 n's. So, we need to replace the missing values with y. Before we write this function, we need to set up the input parameters first. We can assign patient to the dat parameter, and HRT to var name. First, we use the table function to tabulate HRT. The next step will be extracting the value y, which is the value of the highest frequency. We can treat the result from the table function as a numeric vector with names. The names are n and y. We can use the max function to return the highest frequency, which is 3. Then we just need to extract the name that corresponds to 3. We can generate a logical vector by comparing tab result, which is the result from the table function, with high freq. Once we obtain the logical index vector, we can extract the high frequency value, which is y, in the last command. Now, let's complete all the testing code. As you can see, these commands are like what we wrote for imputing a numeric variable, except for the second step, which is to obtain the value of the highest frequency. Other steps are the same. Here's the final version of the function to impute the character variable. Later, we will learn how to write one single function to impute either a numeric or a character variable. Now let's talk about function arguments. The parameters of a function are often referred to as formal arguments. For example, the 2 formal arguments of the impute function are dat and var name. During the function call, we specify patient and GLUC, which are the actual arguments. By default, If we only list the actual arguments in the function call, the first actual argument, patient, passes to the first formal argument dat, and the second actual argument, gluc, passes to the second formal argument var name. This is known as positional matching. The disadvantage of using positional matching is that we must remember the position of each formal argument. If we include both formal and actual arguments in a function call, we don't need to remember the order of the formal arguments. This is called keyword matching. For example, the last two commands are exactly the same, to call the impute function. A function often consists of many arguments. For some of the formal arguments, we often use a specific value, and seldom use other values. In this situation, we can provide a default value for this formal argument. For example, we provide a default value to dat with patient, since we are going to use this data more often than other data. During the function call, we don't need to specify any value to the dat argument, if we are going to use the default value. Since the default value is provided, for the first argument of impute function, for other arguments of the function, we need to use the name equals value format, or keyword matching. In this example, we did not use the patient data, to call the impute function. The value that is provided for the dat argument, foo, overrides the default value. One thing we need to be careful about, when we use a variable name within the function. In the impute function, we must use the square bracket, instead of using the $sign operator, to access a variable from a data frame. When a formal argument is placed within single, or double brackets, the actual argument will be substituted during the function execution. This is called evaluation. The $sign operator does not work, because the $sign does not substitute the actual argument. When we write a function, we often use the if statement to decide whether one or more statements need to be executed. If the condition is true, one or more statements get executed. But if the condition is false, nothing happens. If we have more than one statements that need to be executed, we need to group them within a pair of curly brackets. For example, x is assigned 5. In the first if statement, the condition is checking whether x is greater than 0. Since the condition is true, x is positive is printed. The second if statement is like the first one, except that we need to execute more than one statement if the condition is true. In this situation, we group these statements together, within a pair of curly brackets. In this example, the condition is checking if x is greater than 5. Since the condition is evaluated to be false, nothing happens from the if statement. Then we move on to the next command. We can add an optional else clause to the if statement. When the condition is false, the statements within the else clause are executed. For example, x is assigned 5. Since x is not greater than 5, the two statements within the else clause are executed. One command is printing x is not greater than 5. The other command is subtracting 1 from x. The if statement can also be extended, if you have multiple conditions. In this case, you need to add a series of else-if clauses. The statements within the last else clause are executed, when none of the above conditions are true. This example calculates the central tendency of a given vector, with choices of arithmetic mean, harmonic mean, or median. The return function is nested within the if statement. If a specific condition is true, the calculated result within the condition is returned. The stop function within the last else clause is to print a customized message, and stop the execution if none of the conditions is true. The advantage of using the stop function is that we can control what error message we like to create. It makes the error information more informative. We can also use the cat function to print a customized message. The cat function takes either text strings, or objects names. Text strings need to be enclosed in quotation marks. To control where to print the next line, we can use the \n, which needs to be enclosed in quotation marks as well. This central function is like the previous one, except that it prints a customized message, instead of returning a calculated value. Choosing either returning a value from a function, printing the calculated result, or doing both depends on your programming needs. When writing a function, we often need to add commands for checking if the values that pass to the arguments are legit. For example, are the provided variable names in the given data frame? We can use is.element function, or the %n operator, to examine if variables' names are in the given data frame. The is.element function is to check whether each element in its first argument is part of the second argument. The returned logical vector has the same length as its first argument. The true value indicates that the corresponding element in the first argument is part of the second. Previously we wrote two impute functions. One was imputing numeric variables, and the other one was imputing character variables. We can combine these two functions into one. At the beginning of the function, we used is.element to examine whether the variable name is in the given data frame. If the variable name is misspelled, is.element will return false. And negating the result returns true. In this situation, we print a customized message and return the null value. Alternatively, we can use the stop function to print a customized message and stop the function execution. Then we use the if statement to examine if the selected variable is numeric. The replacement value is calculated depending on the variable type. If the selected variable is a numeric variable, we use the median value of the variable as the replacement value. Otherwise, we will obtain the value with the highest frequency for the replacement value. Logical vectors are often used within the condition in the if statement. In the previous video, we learned how to perform comparisons between logical vectors by using single and single or logical operators. When we use a single and or single or operator, the comparison is performed element by element. These examples illustrate the use of single and single or. There are also double and double or operators. These two operators do not perform element-wise comparisons. They evaluate the expressions from both sides of the operator, from left to right. If the expression contains a logical vector, with a length that is greater than 1, these operators only examine the first element of each vector. When we use a double and operator, the right-hand side of the operator is only evaluated if the left-hand side of the operator is evaluated to be true. On the other hand, when we use a double or operator, the right-hand side of the operator is only evaluated if the left-hand side of the operator is evaluated to be false. This function calculates the square root and log of a given vector. The condition in the if statement checks whether vector x is numeric, or the minimum of x is greater than 0. Since the min function requires its argument to be numeric, checking whether the given vector is numeric needs to be placed on the left side of the double and. If both conditions are true, then the calculations are performed. Otherwise, an error message is generated by using the stop function. Now, let's review what we've learned from this video. In this video, we learned how to create a user-defined function. Creating a function involves several steps, including choosing a function name, deciding function parameters, what statements should be included, and what values should be returned. The statements within the function are generally executed sequentially. We can use the if statement to conditionally execute statements. I hope you enjoyed this video. Please like and subscribe to my channel, and click the bell icon to get new video updates.